Yeah, man, groovy tunes. I am here to party. It's gonna be righteous. Happy Hippie Olsen here. Let's do this. I brought my hacky sack. Circle around, everybody. Woo! Here we go. What? You don't want to play? You want to do math? All right, then, bro. If that's what you want, that's what you're going to get. We got to do some review here. We're working on 10.4b. We're trying to find the surface area and volume of similar solids. All right, everybody, why don't you come on up here just a little bit closer. Let's see if we can take care of this for us all here today. Sure, come on up. Let's see. All right, everybody, here's what we got going on. Number 15, we had two rectangular prisms. All right. I'm using the labels S and B throughout my demonstration here, everybody. I'm using that for small and big. I had the smaller prism and the bigger prism. The smaller prism had a surface area of 40. Well, if we're talking surface area, area's got to be squared, so let's square those dimensions. That makes my proportion 16 over 36 equals 40 over that surface area for the bigger rectangular prism. I got 90 meters squared. Number 16, everybody. I think we're looking at a couple spheres, it looks like. A couple spheres. Surface area again. Let's square those dimensions. Again, using big to small this time. And I got my answer of 2,827.7. Come on over here a little bit more. Let's take a look at 17. Number 17. What do we have here, everybody? We had, they didn't really tell us what it was, did they? Oh, cans, must be cylinders. So we have the surface area, the dimensions for the small, the surface area. The big, we want to know that surface area. Square those dimensions, 673.75 centimeters squared. Number 18, now we went to volume. Notice how I'm now cubing them. So we're looking at looks like a square pyramid. I cubed the big dimension, I cubed the small dimension because they gave me the volume for the big. I'm looking for the volume for the small. After I cubed, I got my new proportion, whole number, 196 millimeters cubed. And here we go, number 19, everybody. Number 19 was cylinders. All right, so once again, we're talking volume, so they have to be cubed. We're giving us the volume of the small. We're looking for the volume of the big. Cube your dimensions, solve your proportion, 13,564.8 feet cubed. And then number 20, did they do it right? You should know by now. No, the dimension should have been cubed, not squared, because we're talking about volume, not surface area. All right, everybody, that's the end of your new material for this whole year. Wow, that was a lot. We are going to do the Chapter 10 chapter review, but not yet. Let's take a quick break from this chapter, and let's talk about, everybody, a couple problems of the day. That's right, problems of the day. I got two of them for you. Let's take a look at this first one, everybody. It's right up our alley, talking about solids. Let's see what we got here, folks. Well, it says if you multiply any number by itself, you're going to get a square number, right? 2 times 2 is 4, making 4 a square number, right? Come on in a little closer. So, a 2 by 2 has an area of 4. 9 is also a square number. Why? Because 3 times 3 makes 9. Is 10 a square number? Of course not. No number times itself is going to equal 10. No whole number anyway. Nor 11, nor 12, nor 13, 14, 15... What about 16? Oh yeah, 16 is a square number. Well, let's keep going. Let's talk about our cubes, everybody. Cubes are numbers you get by multiplying a number by itself and then by itself again. So if I had a 2 by 2 by 2 and I want to know how many cubes there were, that's like volume. Length times width times height. 2 times 2 times 2 is 8. There's 8 little cubes in there. So 8 is a cube number. How about 27? That's also a cube number. It's the next cube number. Why? Because 3 times 3 times 3, length times width times height. Yeah, looks like a Rubik's Cube, doesn't it? But 3 times 3 times 3 is 27. If I gave you 27 little cubes, you can make a big cube. What if I gave you 30 little cubes? Could you make a big cube? Of course not. Of course not. All right, so here we go, everybody. Here is the big question then. So, there's only one two-digit number. That means it's got to be between 10 and 99. That's both a square number and a cube number. I don't think I'm going to give you guys any hints. See if you can solve that one. Okay, everybody? All right. Then, let's take a quick look over here. We got to talk about problem of the day number 2. So, I was driving in my truck the other day when my poor old CD player stopped working. And that's when I thought of this new problem. We got to solve this together, everybody. Here we go. Let's take a look at what this one's going to look like. All right. So, back in the old times, when life was good, we had a thing called records, everybody. We call them vinyl now because that's what records are made out of, vinyl. Well, the old trick question was, how many grooves are there on a record? You want to start counting all those little grooves? Heck no, it's a trick question. There's only one groove on a record. It's a big spiral. So the needle gets put into that groove, and as the record turns, that needle slowly works its way towards the middle of the record when all the songs are finished. Well, we also have a thing called CDs. Well, these are kind of similar, but the opposite. The data is burned into this CD starting from the inside, and then it works its way out. So as the CD spins, the little laser is slowly kind of following that groove, working itself to the outside. So if you guys can kind of imagine way back in the really old days, they'd go to the music studio. The band would go to the music studio, and they'd play, and it would be recorded onto tape. I'm going to take my little snake here, and let's pretend this snake is tape. So the head is the beginning. The engineer at the recording studio says, get ready to play. As soon as he hits record, the tape starts moving. The band plays, and the tape records all of that music. In the end, you get this tape that's kind of just like a big string, isn't it, everybody? Then they transfer that song, that music, from this tape onto the record. And how do they do that? They're basically just kind of winding it up around itself, aren't they, everybody? So again, the beginning of the song is the head. So as the needle starts to play, it just starts working its way around this spiral till it gets to the inside. Now again, you can take that same tape and kind of do the opposite for the CD. Now when you make a CD, the beginning of the song's on the inside here with the head. And now the song starts to play in the CD, and it works its way around to the outside. Hope that makes sense, everybody. All right, that's my little snake. So, here is your problem of the day question part 2. Number 2, I should say. Well, we got our old-fashioned records, now we got our new CDs. Again, they start burning, and it has that spiral going outwards on that CD. So, when my CD player wasn't working the other day, and I got really frustrated, I started thinking about this. So here's what I want you guys to help me solve. I found the diameter of that inner groove of the CD on that inside. I measured from here to here, and I got about 15 centimeters. Then I measured the outer part of the CD, or maybe as far as you could record on that CD, and I found that diameter to be 36.74 centimeters. So what I want to know, everybody, is on a CD, how many of those inner groove songs could fit into the outer groove, if I can use that word, on your CD? I would say the big trick here, everybody, is to remember that circumference is equal to pi times the diameter, okay? If I was to find the diameter of this CD, I could then just put it out nice and straight, and that's how I want you to think of these songs. Get back to me, tell me how many of these inner groove songs could fit on that outer groove. You can do it. Good luck.